Dear students, let us start today's class with a prayer. Direct, O God, our actions and further them by your gracious help, so that every prayer, word and work of ours may begin always from you and be through you happily ended. Amen. Seat of wisdom, pray for us. Don Bosco, pray for us.
Hello my dear students, again we are in our physics class. We are going to start our next chapter, that is motion in a plane, right? So let us see today's objectives. Today's objectives are types of vectors. Some vectors we are going to study today related to vectors itself, their addition and multiplication. Then what is meant by rectangular components of a vector. Then relative velocity as well as projectile motion. Okay, these are the topics we have included in today's class and which we have to deal in our this new chapter. Ready? Okay, so I said beginning topics are related to vectors, right? So just to recall what you have studied related to vectors. Yes, you have studied about two types of physical quantities as scalar quantities and vector quantities. And what is vector quantity also you know. What is vector quantity? Which is having magnitude as well as direction. So about scalar quantities and vector quantities you are having very clear idea. I know that. Examples also you know. Sure, no? Okay. So now we are moving on to our first topic, that is various types of vectors. Let us see one by one. So many types are there which we are regularly using only. I am explaining here. Related to physics, which all vectors we need, we are going to deal with. Okay. So first of all, first type is position vectors. Okay. Position vectors. While taking position vector, when we are explaining the position of a point, how do we use to explain? It is at a distance, let R1. R1 is the point or position of the point from the origin, right? Likewise, when a point is explained with respect to origin, that means distance of position can be explained as the distance between the starting point and end point, or P is the point, its position means how much it is far away from the center or from the origin. That means OP is the distance to express the point P, or OP is known as the position vector. P is the point, position vector is with respect to origin when we are explaining, that itself is known as position vector. So, if P is the point, then OP is the position vector. With respect to origin when we are explaining, that vector form is called the position vector. So, vector OP means R1 is the distance. So, R1 is the position vector, or OP is the position vector whose vectorically magnitude wise equal to R1. Okay. Likewise, with respect to origin, when a vector is explained with respect to origin, then it is known as position vector. OP, OQ are position vectors, right? Then, when we are representing 2 points, that is P and Q, that is not with respect to origin, just taking 2 points, and length of or the magnitude of that distance between those 2 points or magnitude of that vector PQ, it is not with respect to origin, that is known as displacement vector. Okay. So, if a vector is explained with respect to origin, then it is position vector. Or distance between any two vectors are explained, then it is known as displacement vector. Okay, displacement vector. So here OP and OQ are position vectors, then PQ is displacement vector. Fine. Then another type of vector is zero vector. If the magnitude of a vector is 0, when we are subtracting two similar quantities, we will be getting an answer as 0. But if two vectors are subtracting equal magnitude and opposite direction when we are adding, or two equal magnitude, two equal vectors are subtracting, surely magnitude will be 0. So, vector but magnitude is 0, then such vectors can be called as zero vector. A vector whose magnitude is 0 and having a direction. When subtracting two vectors, that case it is significant. So, when two vectors are subtracting and if the magnitude is 0, then that vector can be called as zero vector. Okay. Then, if the magnitude is 1, unity, it can be called as unit vector. Magnitude of a vector quantity is 1 or unity, then it can be called as unit vector. In maths, you might have studied the definition also. A unit vector x or a represented with such a symbol called cap, x cap, is equal to magnitude of the vector divided by modulus of that vector. Maths, you have studied the definition. This is the definition of a unit vector. A vector dividing with its magnitude, then the answer will be 1. So, if the vector whose magnitude is equal to 1, then it can be called as unit vector. Usually, unit vector is represented by such a symbol called cap. So, x cap is a unit vector having a direction, magnitude is 1. You know what is the use of this? If we want to convert any scalar quantity to a vector quantity, we can multiply with unit vector. So, that scalar will be converting into vector without a change in its magnitude, right? Likewise, a unit vector can be used. Magnitude is unity, but it is having a direction, right? One more thing, when we are taking this vector in x direction, y direction and z direction, their specified unit vectors are there. Therefore, let us see those unit vectors. If we are taking a vector, unit vector along the x-axis, its representation is small letter I. So, I cap is the unit vector along x-axis. Similarly, unit vector along y-axis is j and z-axis is k. So, I, j, k are unit vectors along x, y and z axis, standardized, right? See, x, y and z, all the three are in three mutually perpendicular directions. So, they are known as orthogonal unit vector, mutually perpendicular unit vector. So, I, j, k are what? Orthogonal unit vectors. Okay, these are some of the important types of vectors we have to see. So, which all vectors we have studied? Position and displacement vector, then unit vector, zero vector. In unit vector itself, orthogonal vectors. What is meant by orthogonal? 90 degree. Okay, so 90 degree each other. So, I, j, k, cap, all those things should be there. Okay. Okay, now our next one is, so beginning vectors we got. Now, how can we add these vectors? So, our second topic is addition of two vectors. If it is scalar, no problem, simply the magnitude can be added, but direction is there, it is difficult. So, in order to add two vectors, we have to follow certain rules, right? Here, in order to add, we are studying two rules. First one is triangle's law of vector addition. Okay, triangle's law of vector addition. According to triangle's law, if we are having two vectors, vector A and vector B, in triangle's law, two vectors, okay, one vector A and one vector B. Okay, two vectors are there. We have to add these two vectors. So if we want to follow triangle's law of vector addition, we can keep the second vector as the continuous side of the first vector. Okay, according to the triangle's law, if we want to add two vectors, the second vectors can be kept as the continuous side of the first vector, and by completing that triangle, what is the length of the third side? That will be the resultant. Okay, according to triangle's law, if two vectors are acting as the two continuous sides of a triangle, then the third side will be the resultant of these two vectors. But when we are completing the triangle, how we used to draw the triangle? Like this, going upward, coming back, then it will be completed. So its original direction is downward, but our vector should be taken in the opposite direction. So we can state that in triangle's law, if two vectors are taking as the two continuous sides of a triangle, then the third side taken in opposite order, opposite direction will be the resultant of these two vectors. Okay, let the angle between the vector, direction of the vector A and direction of the vector B is theta. Then let us find out what is the resultant vector's value and what will be the resultant vector's direction. Shall we do a small derivation? So for doing our derivation, let us consider the triangle which is made up of these two vectors A and B. Okay, so vector O, vector, one vector is OA, next vector is AB. So magnitude is given. A and B are the two vectors. We kept A and B as the two continuous sides of a triangle OAB. Then as per that statement we have studied, OB, let this be value B, let us take it as R. That means R is the magnitude of sum of A and B. Okay, after adding A and B we are getting R. So now we are going to find out what will be the value of R. Right? Completing the proof, let us complete this triangle by extending the direction of the vector A, and let it be name it as P. Okay, OAB is the triangle. In order to complete this triangle as a right angled triangle, extending the direction of A and getting a point P, according to matching with the diagram exactly given there, let it be E. The point is E. Okay. Now, in order to show the direction between the direction of the vector A and vector B, theta is the angle between them. Right? Okay. Our aim is to get the value of R. Now, the right angled triangle is here. So, how can we get the value of R? Like R as acting as the hypotenuse of the triangle. R square is equal to base square, hypotenuse square is equal to base square plus altitude square. Base means the length OE, altitude means the length BE. So according to Pythagoras theorem, hypotenuse square is equal to base square plus altitude square. We have to find out what is OE and what is BE. Right? In order to find out OE, you know, OA is A. But AE we have to find out, right? Similarly, the altitude also BE we have to find out, right? For that, let us consider the triangle ABE. From the triangle ABE, since angle we know, theta we know, in order to find out the adjacent side of theta, let us find out what is cos theta there. What is cos theta? Adjacent side divided by hypotenuse, that is AB. AB is the vector B here. Therefore, AE, the unknown distance AE is equal to B cos theta. Similarly, from the same triangle, if we are taking sin theta, opposite side have to be considered. So, sin theta means opposite side BE divided by hypotenuse, that is B. Okay. So, unknown distance or the altitude B is equal to B sin theta. So, you can see A is equal to B cos theta, B is equal to B sin theta. By knowing those distances, we can complete it, right? Then what will be r square? R square is equal to OE, which is the sum of OA, that is vector A, AE, that is B cos theta, its whole square. So, A plus B cos theta whole square plus BE square. BE means B sin theta. So, plus B sin theta whole square, right? Like OE square plus BE square. Now, open the bracket, it is of the form A plus B the whole square. So, it will be A square plus B square plus 2AB. Correct? Second one also, B sin theta square, that means B square sin square theta. Okay, now you see A square, here B square cos square theta there, B square sin square theta there. So, we can add both. B square while keeping outside, inside we are getting sin square theta plus cos square theta, which is equal to 1. Therefore, how can we modify this? A square plus B square plus 2AB cos theta. That is the magnitude of our resultant vector. That means R is equal to root of A square plus B square plus cos theta, 2AB cos theta. Okay, A square plus B square plus 2AB cos theta. That is the magnitude of the resultant vector after adding A and B. What is theta? Angle between A and B. Okay. Now we have to find out the direction, because vector is having magnitude as well as direction. Magnitude we got here. Direction used to say in terms of angle. Therefore, direction of R, let this angle be alpha. So, direction of that resultant vector we can calculate by taking that angle alpha. Usually, directions are in terms of tan. So, what is tan alpha we have to take? What is tan alpha? Opposite side by adjacent side. BE by OE. What is BE we have seen? B sin theta. What is OE? A plus B cos theta. So, direction is A plus B cos theta, tan alpha is equal to B sin theta divided by A plus B cos theta, and magnitude is root of A square plus B square plus 2AB cos theta. Okay, so using triangles law, we can add two vectors. This is the first method, triangles law of vector addition. Similarly, parallelogram law also can be used. Let us see that also. That means, in the case of parallelogram law, if the vectors are coming like vector A and vector B as coming like the two adjacent sides of a parallelogram, separated by an angle theta, are coming as the two adjacent sides of a parallelogram. Then, after completing that parallelogram, what is the diagonal passing through that point of intersection? That will be the resultant vector. Okay? According to parallelogram law, if two vectors are acting as the two adjacent sides of a parallelogram, then the diagonal passing through their point of intersection will be the resultant. If we want to take the proof of this, similar manner, A is the first vector, Then B is the second vector. By completing the parallelogram, opposite sides are having equal in magnitude. Because of that, by extending the vector A like the triangle's case, we can prove its result also same like triangle. Parallelogram law also statement is different, but while adding parallelogram manner also answer is same. That is true. Now when two vectors are adding, answer should be same whatever be the method we are using. So parallelogram law also we can use for adding two vectors. It's a theorem also, it's a proof also the same manner, because opposite sides of a parallelogram are same, equal in length. Okay, so these are the two laws or rules for finding the addition, adding two vectors. So once again, which all are the two? Triangle's law of vector addition and parallelogram law of vector addition. You just go through the slide and read it. Triangle's law. Okay, what is parallelogram law also you see? That means magnitude is same, direction also same, only the method is different. Okay? Okay, right? So addition is over. So types of vectors, addition of vectors finished. Next is multiplication. Okay? Multiplication of two vectors. If we are saying, that is not scientifically we can say, but when we are just using the common sense, when we are writing two vectors, we used to write A into B like this as well as A into B like this, isn't it? When we are writing in mathematics, simply we are writing either into or dot. But in vector manner, when you are using, both are having different meaning. That means when we are multiplying two vectors, two types of multiplications are there. Two types of product formations are there. Okay, so when two vectors are taking the product of two vectors, two types of product are there. One is called cross product and the other one is called dot product. So two types of product of vectors are of two types, cross product and dot product. As the symbol we are using, if into, it is called A cross B. If dot sign is using, that also product of two vectors, but it is dot product. So two types of products are there, cross product and dot product. How it can be differentiated? That is, when two vectors are multiplying, if we are multiplying the magnitude of those vectors and considering sign of the angle between them, then it is the cross product. That means answer also will be a vector. Final answer also will be a vector quantity. Because of that, cross product is also known as vector product. Right? But when we are multiplying in the dot form, dot product of two vectors are product of the magnitude of the vectors and taking cosine of the angle between them. AB into cos theta. Then that vector sum is called dot product. Its answer will be a scalar quantity. So dot product is known as scalar product. Cross product is known as vector product. Cross product's answer will be a vector quantity. Its direction will be, what is the direction of A and what is the direction of B? Perpendicular to that will be the direction of the resultant vector. Okay, perpendicular to both A and B will be the direction of resultant vector. But dot product means we are considering the cosine of the angle between them and final answer will be a scalar. No direction will be there. Okay, so what we have studied now? Two types of multiplications are possible, products are possible, that is scalar product and vector product. You just go through the slide, what is scalar and what is vector. Okay, explanation also. Okay, fine. Formula A cross B is AB sin theta and A dot B is AB cos theta. Okay, one is scalar product and other one is vector product. Fine. So we have studied addition, multiplication. Fine. Now we are moving on to another part, rectangular components of a vector. Right? That is, if one vector is in a plane, one vector is in a plane, let the vector is represented as A, one vector. It is not along the x-axis and not along the y-axis. Therefore, if we want to add such vectors, not along the x or not along the y, we have to take the component of this vector in the x direction and y direction. Then only directly we can add. Okay, so by extending or taking the components of a vector along the x-axis and y-axis, those components are known as rectangular components. That is, A is the vector, it is having a component along the x-axis and A is having a component along the y-axis. That means vector A will be sum of Ax along the x direction, so multiplying with unit vector in the x direction. Then component in y. So vector A is the sum of Axi plus Ayj. What is Ax? Component in x direction, like x coordinate. Because when one point is taken, it will have x coordinate and y coordinate. Max you have studied. Similar thing. X coordinate is known as x component. Y coordinate is known as y component. But what will be its magnitude? Let us see that. Let us see resultant vector. Usually the resultant vector's direction is the direction of the resultant vector's direction means angle wise I said. Let if theta is the angle between x direction and that vector A, then when we are taking x component and y component, since this is theta, what will be the opposite side? Yes, take sin theta. Sin theta will be equal to opposite side. If we are naming it, let OPQ. Opposite side PQ. Sin theta is equal to opposite side by hypotenuse, that is A. So PQ, this length is equal to A opposite side, A sin theta. What will be adjacent side? You can guess. Adjacent side of theta, that means we have to calculate cos theta, that is adjacent side by hypotenuse. So you can see Ax, x component will be equal to A cos theta. This is y component will be equal to A sin theta. In short, when there is a vector in a plane where that vector is making an angle theta, that side it has to be taken cos theta. So x component will be vector into cos theta, y component is vector into sin theta. That is A cos theta and A sin theta are the x component and y component of the vector A. X component and y component can be differ if theta is changing. Where theta is made, there adjacent side is coming, so that side will be cos theta. Okay. Further while doing it will be more clear. Now you just get the idea. Rectangular components means components which are mutually perpendicular. That means x component and y component. By calculation we can see Ax means A cos theta and Ay means A sin theta. So Ax and Ay are the rectangular components of the vector A. Okay. Ax and Ay are the rectangular components of the vector A. Okay. So rectangular components are clear now. Now we are moving to the next one, relative velocity. Okay. Relative velocity, that one is, so the vector part is over. Relative velocity is also calculating using this vector addition and all. So there we are applying, but before that we should know what is relative velocity. Okay. Relative velocity, the word relative, that means with one is explaining with respect to the other one. That is, when two bodies are moving, okay, when two bodies are moving, then velocity of one body with respect to the other one, not original velocity. When two bodies are moving together, then what is the velocity of one body with respect to the other one is known as relative velocity. One body, velocity of A we can say as VA, velocity of B let us say that VB. Then velocity of A with respect to B is velocity of A minus B. It will not be the original, true, no? When both bodies are moving, both will have their own velocities, but for the second body, when it is looking at the first moving body, it will not feel that it is having its original velocity. It will be the difference between their velocities. So, what is the relative velocity? When two bodies are under motion, velocity of one body with respect to the other one is relative velocity, and it can be calculated as relative velocity of A with respect to B is using as the subscript velocity of A with respect to B, that is VAB is equal to velocity of A minus velocity of B. If the direction is changing, according to that, one becomes positive and one becomes negative. So, it will be, result will be changing. But basic formula is VAB, velocity of A with respect to B is VA minus VB. Okay. When both are, A is moving in positive direction and B is moving in negative direction. Then when we are calculating velocity of A with respect to B according to the formula VA minus VB, see VA in positive direction, VB, what is the direction of VB? Negative direction. So, VA minus VB means since VB is in the opposite direction, VA minus VB is opposite direction of VA. So, VA minus VB means opposite direction of VA. So, it will be VA plus VB. This is what I said, when the direction is changing according to that vector, that means direction we have to consider. So, the result will be changing. So, now same direction means VA minus VB, opposite direction means VA plus VB. Actually, what is happening? VA minus negative direction of VB, not in the same direction of VA, opposite direction of VA. So, negative VB, thus it is getting VA plus VB. This is what is known as relative velocity. When two bodies are moving, velocity of one body with respect to the other one is relative velocity. Now, if we are considering the movement of the body in a plane, let A is moving in one direction, B is moving in another direction. Okay, velocity of VA and VB, but they are in different direction. So, let say it is easy to show like this. A in one direction in a plane with an angle theta. VA and VB, easily I will say VA and VB, two vectors, two different directions. Okay, how can we find out velocity of A with respect to B? What should we do? According to the formula we have to write VA minus VB. Subtraction of vectors we haven't studied. So, we can write it as VA plus minus VB. Addition of vectors we have studied. So, minus VB we can write plus negative VB. So, in the diagram how can we show that? VA direction is there, plus VB is this. So, what will be minus VB? So, we need the sum of VA and this VB. Okay, according to parallelogram law we can do that, isn't it? The resultant will be the diagonal passing through the point of intersection of these two vectors when they are completing it as a parallelogram. isn't it? Likewise, we can complete. See the resultant with the help of this slide we can see, right? So when we are taking the resultant using the formula a square plus b square plus 2ab cos theta. But theta, you know, theta is the angle between VA and minus VB. Because of that, it is taken 180 minus theta. So see the resultant. According to parallelogram law, we can find out what is the relative velocity of VAB. So we are getting velocity of A, VA square plus VB square minus 2 VAVB cos theta. And also direction tan alpha, that is VB sin theta divided by VA minus VB cos theta. Okay, likewise we can calculate relative velocity. Clear? So relative velocity also you understood. When two bodies are in motion, you have to specify. In such cases only relative velocity comes. Okay? Okay, then we are moving on to the last part of today's class, that is projectile motion. Okay, any idea about what is projectile motion? What is a projectile? Okay, any idea? Yes, anything moving in space can be called as a projectile. That motion can be called as a projectile motion. But we will be adding one more term, without the assistance of any force, any fuel, only under the effect of gravity. If that body is moving, it can be called as projectile motion. When we are throwing a stone, with our force we are throwing it. Naturally, we need a starting force to move a body. So the body is moving, but after some time, it will be moving only under the effect of gravity. Then its motion can be called as projectile motion. Stone can be called as projectile. Okay, the body which is moving can be called as projectile. So when we are throwing a body or a projectile, it is moving in air, and after reaching a certain height, due to gravity, it is coming back. That means a particular shaped path it follows. It is known as trajectory. Motion is called projectile motion. The body which is moving is called projectile. Path followed by the body is called trajectory. Okay. And how much time it is taken to come back to the ground? It is known as time of flight. Now we are going to calculate all these. Okay. What all things? What is the path followed? Equation of trajectory we want. Then how much height it travels. Maximum height obtained we have to calculate. What is the total time taken for its traveling? That is called time of flight. Time of ascent is there. Time of descent is there. Total time is called time of flight. All these we have to calculate. And finally, what is the total distance covered in the ground, on the ground, from the starting point till it is coming back to the ground? How much distance covered? It is called horizontal range. Trajectory, time of flight, horizontal range. These expressions we have to calculate. Okay, let us see. Here we said projectile motion means it is moving only under the effect of gravity, which is acting vertical direction or horizontal direction. Yes, fine, vertical direction only. Therefore, when we are considering this body's movement, let velocity of the body is u, starting velocity. Okay, so it is having x component as well as y component. But what's the difference? Let angle also theta, always y component, vertical component will be under the effect of gravity. So motion in the vertical direction will be non-uniform, but motion in the horizontal direction will be uniform. Motion in x direction of, for this particle, x component and y component there, then x direction it is uniform motion, y direction it is non-uniform motion. In order to get the equation of the trajectory, we have to consider the distance travelled in x as well as y direction, where one is uniform and other one is non-uniform. Okay, yeah. So here, by taking the component of this u in x direction, since theta is made there, x component will be u cos theta and y component will be u sin theta. Therefore, distance travelled in x direction, x component or x coordinate of this particle x will be equal to, since it is uniform motion, we can take velocity in x direction is equal to distance by time. Velocity in x direction is equal to distance by time. Since distance is in x direction, let us take it as x. Velocity in x direction is u cos theta. Therefore, we can write for the particle u cos theta is x by t. Okay. So, distance in x direction we got. Distance in y direction also want to calculate. Then after combining both, we will be getting the equation of trajectory. In order to get the displacement in x y direction, non-uniform motions equation, that is s equal to ut plus half at square we can adopt. S means distance travelled in y direction, ut plus half at square. Okay. U, velocity in y direction, starting velocity in y direction is 0. So, first term will be 0. Then, second term, half a t square. What is a here? Acceleration due to gravity. Since the body is moving in the upward direction, it has to be taken as negative. Okay, so we can write y component is equal to half of negative g t square. But since we want to add x component also there, from this we can get the expression for t as x by u cos theta. By substituting here, we can write y is equal to minus half g t. Instead of t, we can write x by u cos theta. Okay. Now, one more is there, but even though we are considering the y direction, beginning we said, I said starting velocity is 0, but here already we said u sin theta and u cos theta are the components of initial velocity u. So, here we have to add that also. Instead of taking u as 0, ordinary case u is 0, in this case it will be u sin theta. Ordinary case we can take 0, but here already it is said components are u sin theta and u cos theta. So, here we have to consider initial velocity as u sin theta. So, it will be getting us u sin theta, there also t. So, y is equal to u sin theta into, instead of t, x by u cos theta minus half g the other term. Now, by modifying we will be getting the equation for trajectory. Okay, so here ordinary case it is 0, now u is equal to u sin theta. In this case u is equal to u sin theta, and see u sin theta reducing, and when it reaches the maximum height it becomes 0 there. Okay, so let us modify the equation. U and u cancels, sin theta by cos theta becomes tan theta. So, equation is x tan theta minus half g x square by u square cos square theta. This is the expression for trajectory. Okay, it has to be studied. Initial velocity, don't forget, ordinary case 0, but here it is, because ordinary thing is just dropping now, so 0, but here u sin theta is the initial velocity. If it is 0, other way it happens. In this projectile motion, u sin theta, so accordingly we will be getting the final expression as x tan theta minus half g x square by u square cos square theta. Okay. Our next one is, we have to calculate what is the time, total time taken to reach. So that is the next one, expression for time of flight. For that, time can be taken as two parts. Time taken to reach the maximum height, time of ascent. That will be equal to time of descent. So total time will be time of flight. Let us see what is the time. We can adopt V equals U plus AT. Velocity in y direction is equal to initial velocity in y direction. Don't forget that. How much is it? AT. Substitute. When we are taking only the upward motion, final velocity will be 0. Initial velocity is u sin theta. Acceleration is negative g. Time is time of ascent. So we can write u sin theta is minus gt, or t is equal to u sin theta have to be taken to the other side. G want to bring to the denominator. So time of ascent is equal to u sin theta by g. Time of descent also will be same, u sin theta by g. Same time will be taken to come back. Therefore, time of flight, capital letter T is equal to 2 times this, that is 2 u sin theta by g is the formula for time of flight. 2 u sin theta by g. Okay. Now, the third one. What is the third one? Horizontal range. Since it is x direction, distance travelled in x direction is equal to velocity in x direction into time taken to reach that point. What is velocity in x direction? U cos theta. What is the time taken to come back to the point? Time of flight, that is 2 u sin theta by g. U cos theta, u sin theta, 2 u sin theta, 2 sin theta cos theta is sin 2 theta. Maximum formula there. I don't know whether you have studied or not. 2 sin theta cos theta is sin 2 theta. So we can write u square sin 2 theta by g. U square sin 2 theta by g is what? Horizontal range. Finally, one more is there, maximum height. What is the maximum height? That means vertical distance. Okay, for calculating that vertical distance, again we can use S is equal to ut plus half at square. Okay, ut plus half at square. So when we are taking the distance in x direction, y direction as h, in the starting velocity in y direction is u sin theta. Time taken is, see, the time taken is equal to time of ascent. Okay. Height, that is the expression we have started, but see, h is equal to u sin theta, then time is time taken to reach the maximum height, half a, acceleration in the negative direction, minus g, again t, time of descent. So if we are using this formula, so many places time of ascent we have to substitute, then much of calculations are there. Therefore, we can adopt one simple equation. 3 equations are there. S is equal to ut plus half at square. There it is S. V square is u square plus 2as. That equation also there. So here we can use, but time of ascent to be substituted. Since it is more complicated, I have shown that because both the ways we can calculate, because in both the equations S is there. But there time of ascent, then so many calculations we have to do. That way also we can do. Okay. But if we are using this equation, very easily we can do. Since we are taking the time of, means ascending time, final velocity is 0. Initial velocity is u sin theta. Therefore, u square will be u square sin square theta. starting velocity in x direction. Acceleration is acceleration due to gravity minus g. S is distance in y direction. Okay, no confusion, no, because S is coming in both the equation. Previous equation you can use, so that so many calculations are there. Therefore, this method also we can do. Since it is easy method, going ahead with that method. So, u sin theta, initial velocity in y direction, acceleration in vertical direction which is minus g since it is moving upward. S, height in x direction represented as h. Calculate it. U square sin square theta minus 2gh. No substitution is needed here. Therefore, h we can calculate it as u square sin square theta by 2gh, while taking g to this side plus 2g. Very easily we got. Other way also, those who want to try the other way, you can try it, but t should be substituted as time of ascent. Okay, so this is the easy step. H max can be calculated like this. So many formulas we have derived. Then derivation you have to study well, but let us see all the formulas once again. In projectile motion, equation of trajectory we have derived, that is x tan theta minus gx square by 2u square cos square theta. Time of flight 2u sin theta by g. There first we have calculated time of ascent, then doubled it. Then range of projectile. Range of projectile means distance moved in x direction. For that only x component we have taken, and uniform motion also we have considered, and we got it as u square sin 2 theta by g. In all these three equations, only one direct equation we can use. But while coming to height of the projectile, two methods are there. But easy method is v square equals u square plus 2as. By substituting there, we will be getting the result as u square sin square theta by 2g. As per this diagram, instead of theta, since it is the starting angle, original angle, in the symbol theta 0 also used in certain cases. So, just ignore that. Theta 0 or theta is the same. Okay, so this is the end of today's class. So, let us recap what all we have studied. Beginning we have studied various vectors. Then how can we add vectors as well as how can we multiply. Then rectangular components. After that relative velocity, and we concluded with derivations of projectile motion. Okay, various manner it can be done, which is easy, that way you have to follow. Okay, so this is the end of today's session. After this, let us do all the questions given in the worksheet. Okay, after going through the chapter, complete chapter we have done now. So after going through the entire chapter, attempt all the questions given here. Okay, okay, then after studying you have to answer the question. Okay, derivations also there. Okay, fine, let us see in our next class. Thank you very much, my dear students.